On the 12th of August, 2026, the sky over parts of Europe will go dark in the middle of the day. For about 2 minutes, the sun will vanish behind the moon, and its ghostly outer atmosphere will blaze into view. It will be the first total solar eclipse to cross mainland Spain in over a century, and the first over Western Europe since the Great Eclipse of 1999. We treat it as spectacle, but a total eclipse rests on a coincidence so exact it feels designed. The moon is small, the sun is a star, and yet from here one can perfectly hide the other. Today, let's make visible why that fit is possible at all, why it doesn't happen every month, and why you're lucky to be alive in the brief window of history when it happens at all. Hold up a coin at arm's length and you can blot out the moon. Hold it closer and you can blot out a mountain. What matters for covering something isn't its true size. It's its apparent size, the angle it spans in your view. Here's the coincidence. The sun is about 400 times wider than the moon, but it's also about 400 times farther away. Those two factors almost exactly cancel. So in our sky, the sun and the moon appear almost the same size, each spanning about half a degree, roughly the width of a pea held at arm's length. Nothing in physics requires this. It just happens to be true right now. That near-perfect match is what makes totality possible. When the moon slides exactly in front of the sun, it can just cover the blinding disk and no more. And because it only just covers it, something extraordinary is revealed. The corona, the sun's faint outer atmosphere, million-degree plasma normally drowned out by the glare. You can only see it from the ground during those few minutes of totality. And in the last seconds before totality, the final sunlight streams through valleys on the moon's rugged edge, breaking into a string of brilliant points called Baily's beads. The last one, blazing beside the ring of the corona, is the famous diamond ring. But the moon's orbit is an ellipse, so its distance changes. When the moon is a little farther, it looks slightly too small to cover the sun, and you get a ring of fire instead, an annular eclipse. We live in the era when it still, often fits. Now the puzzle. The moon passes between the Earth and the sun once every lunar month, at every new moon. So why don't we get a total eclipse every 29.5 days? If the moon orbited in the exact same flat plane as the Earth goes around the sun, we would. There'd be an eclipse every single month. But it doesn't. The moon's orbit is tilted by about 5 degrees. 5 degrees sounds tiny. But across the sky, it's enough that most months the moon passes above or below the sun and its shadow misses the Earth entirely. The tilted orbit crosses the flat plane of Earth's path at just 2 points. Astronomers call them the nodes. Think of them as the only 2 doorways where an eclipse can happen. For a solar eclipse, 2 things must line up at once. It has to be a new moon, and the moon has to be near one of those nodes. Miss the node, and the shadow sails past into empty space. That double condition, right phase and right place, is why eclipses are occasional, not monthly. Most new moons simply happen too far from a node. The nodes line up with the sun's direction roughly twice a year. Those alignment windows are called eclipse seasons, and they're the only times eclipses can occur. That's why, across the whole Earth, we get somewhere between 4 and 6 eclipses in a typical year, solar and lunar combined. Not rare, globally. The rarity is about to become personal. The moon casts 2 shadows, a broad, faint outer cone, the penumbra, where the sun is only partly blocked, and a narrow, dark inner cone, the umbra, where the sun is hidden completely. Only inside the umbra do you see totality. And where the umbra touches the Earth, it paints a thin ribbon just 100 or 200 kilometers wide, racing across the surface at thousands of kilometers an hour. Stand a little outside that ribbon and you'll see a partial eclipse, the sun with a bite taken out. Only inside it does day turn to night. That thin ribbon is the whole story of why totality feels so rare. On any given eclipse, the path of totality covers well under 1% of the Earth's surface. So while the planet as a whole sees eclipses often, any single spot on the ground waits a long time for the shadow to fall exactly on it. On average, a given location sees a total eclipse only about once every 3 to 4 centuries. That's why people fly across the world to stand inside the path for 2 minutes. It isn't the eclipse that's rare. It's the eclipse finding you. And here's the part that turns coincidence into privilege. The moon is drifting away from us. Tides between the Earth and Moon are slowly pushing it outward by about 3.5 centimeters a year, roughly the rate your fingernails grow. As it recedes, it appears smaller in our sky. Run the clock forward, and there comes a point when the moon is simply too far to ever fully cover the sun. After that, every solar eclipse will be annular, a ring, never a total blackout. That day is very roughly 600 million years from now. Run the clock backward, and there was a time the moon loomed larger. We happen to live in the window where the fit is close enough to be perfect. A cosmic accident of timing, and we're inside it. This alignment isn't just beautiful. It's been one of science's sharpest tools. Totality is the only natural chance to study the corona and the sun's edge from the ground. In 1919, astronomers used a total eclipse to watch starlight bend as it grazed the darkened sun, and confirmed that gravity warps space, exactly as Einstein's general relativity predicted. An eclipse helped prove our modern picture of gravity. And eclipses aren't random. They repeat. After a period of 18 years, 11 days, and 8 hours, almost the very same eclipse happens again. Astronomers call this rhythm the Saros cycle. Those extra 8 hours matter. In that time, the Earth turns another third of the way around, so each repeat of the eclipse lands about 120 degrees of longitude farther west. The Babylonians noticed this rhythm around 2,700 years ago. By carefully counting the cycle on clay tablets, they could predict eclipses long before anyone understood the orbits behind them. Which brings us back to the 12th of August, 2026. The moon's umbra will sweep across Greenland, Iceland, and northern Spain, with the deepest darkness lasting up to about 2 minutes and 18 seconds. For everyone in the path, the temperature will drop, the horizon will glow like a strange sunset in every direction, and the corona will appear. For a large stretch of Europe outside the ribbon, it will be a deep partial eclipse. So when it happens, remember what you're really seeing. Not just a shadow. A coincidence of size and distance so precise that a small gray rock can perfectly erase a star, for a few minutes, in a narrow band, in a brief chapter of cosmic history. No law of nature had to make the moon fit the sun. It simply does for now for us. On the 12th of August, if you can, look up.